In this video, we're going to do the following problem. A new photocopier works 3 times as fast as an old one. When the machines work together, a university can produce all its staff manuals in 6 hours. Find the time it would take each machine working alone to complete the job. So in this problem, we're going to need to find 2 different values because we're asked to find the time it would take each machine if it were working alone. We're going to start off by organizing the information in the problem into a table. So the first thing we're going to do is answer the question, which machine is working? And we'll put that in one column. And then we're going to list the rates at which they work in 2 different ways. One is the number of hours it takes, and this is going to be the number of hours it takes to do one job. And then we're also going to include the information about how much of the job or what fraction is done in 1 hour. Okay, so we have a new photocopier and an old photocopier. So we'll enter those in as machines. So we have a new copier. And we have an old copier. And we have the 2 together. The only information we're given in the problem in terms of numbers of hours that it takes one of these to do the job is when they work together, it takes them 6 hours. And that means that in 1 hour, they would get 1/6 of the manuals or 1/6 of the job done. The other piece of information that we're given relates the speed of the new copier to the speed of the old copier. And the problem says that the new photocopier works 3 times as fast as the old one. That means that the new one is faster than the old one. So we'll give the new one a variable of x to say it's going to take it x hours to complete the job. And the old one was going to take 3 times longer than the other one. So that means that in 1 hour, the new copier is going to do 1 over x of the job, and the old copier would do 1 over 3x of the job. And it's these values in the last column that we'll be able to use to build an equation. And we're going to do it by looking at the fraction of the work that's done in 1 hour. So we'll have the fraction that the new copier does plus the fraction that the old copier does, and that'll give us the fraction that they do if they work together. So from the table, we can see that the new one does 1 over x in 1 hour, the old one does 1 over 3x in 1 hour, and together they would do 1/6. To solve this, we're going to look for a least common denominator, which in this case is going to be 6x. So we'll multiply the numerator and the denominator of the first fraction by 6, and we'll multiply the numerator and the denominator of the second fraction by 2, and we'll multiply the numerator and the denominator of the last fraction by x. And that gives us the equation 6 divided by 6x plus 2 divided by 6x is equal to x divided by 6x. and that tells us that 8 is equal to x. Because the denominators here are all the same, so in order for this statement to be true, that means that the numerator of the first plus the numerator of the second needs to be equal to the numerator of the fraction on the other side. So going back to our table of values that we organized, x is equal to 8, and the old copier then is 3 times x, which is going to be 24. And remember, these were the numbers of hours that it takes them. So if we're going to write a sentence answer, that means that the new copier takes 8 hours alone, and the old copier takes 24 hours if working alone. I hope you found this helpful.